Recording in progress.
Hi students, in this lecture we are going to solve few problems based on the definition of work done. See first problem. See what is given. A block of mass 1 kg is placed at 2 I cap plus 0.5 J cap. It is taken to a point 5 I cap plus 4 J cap. One of the forces acting on the block is 10 I cap. Find the work done by that force. And given all are in SI units. So given initial position vector, final position vector, given force vector and mass of the block, right? See how we solve this problem. So first write down the given data. So force given F is 10 I cap. It is in Newton. Initial position vector. Let us take it as R1 bar. That is given 2 I cap plus 0.5 J cap. Next, given final position vector, that is 5 I cap, 5 I cap plus 4 J cap, right? So we have to calculate what done by that force. So here force is a constant, so we can take directly W equal to F bar dot S bar, F bar dot S bar. And from this, we can calculate S bar. S bar equal to, it is R2 bar minus R1 bar. That is now displacement vector. See how much we get. 5 minus 2, that is a 3. 3 I cap. 4 minus half, that is 3.5 J cap, right? So we got here displacement vector and we are given force vector. This is now substitute here 10 I cap dot 10 I cap dot displacement vector is 3 I cap plus 3.5 J cap. Now we can say I cap dot I cap, that is 1. So 10 into 3, that is now 30. Next, I cap dot J cap, that is 0. That means what done? It is now 30 joule, right? But remember, here the main purpose of giving this question is not to solve like this. So we have learned that whenever force is a constant, we can take component of displacement along a force, right? Now see here, force is along x-axis. If you see, this is now displacement. It's a component along x-axis, that is a 3. Then directly we can take 10 into 3. Force is along positive x-axis and there's a component also along positive x only. So directly it is 10 into 3. That means without making this one F bar dot S bar, directly we can write. So that is the main intention of this problem. So directly from here you can say displacement equal to 5 minus 3 along x-axis. That 3 into 10, that is now 30. So you have to keep in mind whenever force a constant, directly focus what is the displacement component along that force. That simplifies the problem. Okay. See next problem. Right. Now this one. A block of mass 2 kg is placed at origin. A variable force F equal to 2x Newton is acting on the block, where x is the position coordinate of the block. Find the work done by that force during the time it reaches x equal to 3. Right. So the purpose of giving this question is, this is now variable force. So how to calculate work done when force is variable? Okay. Right. Now see how we are solving it. Initially block was at origin. Force given 2x. Right. First of all, let us write down given data. Given there is a block at x equal to 0 means origin. Given force is F equal to 2x, which is variable, and given x is now position coordinate of the block. That means when block was at origin, no force, right? Getting it? When block was at origin, no force. Now force gradually increasing when it is moving, right? Okay, now see how we calculate. When it is reaches x equal to 3, we have to calculate work done. That means we are knowing here displacement, right? 0 to 3. But force is not a constant. Okay. So what we are doing is here, see definition part, integral f bar dot ds bar, integral f bar dot ds bar. Okay. Assume that here, given at origin, initially assume block was moving. Initially block was moving. The relation is that when x equal to 0, F is 0, right? Net force is 0 at this point. Okay. If block is not having any velocity, block does not move because net force 0, velocity 0. So here condition is that block has some velocity at x equal to 0. Because of that velocity, its coordinate is changing. Since coordinate changing, force acting on that is now changing. That means now block moves with acceleration. Okay. Right. Now focus carefully. It is integral. Let us take at one instant block is somewhere here and x is its position coordinate. Now I am taking from here to a small displacement dx. That means x to x plus dx. Now in this small displacement, work done by this force. I am repeating. Let us take at one instant block is somewhere here and x is its position coordinate. Now we are taking a small displacement dx. That means now its position coordinate is x plus dx. Okay. Then work done in this small displacement, force is 2x, displacement is dx. And between this force vector and displacement vector, angle is 0. It is now cos 0. Then see what we get. I can take 2 outside. Remaining is x dx. That becomes x dx. So 2 into this becomes now x square by 2. Okay. So 2 gets cancelled. Now take limits x equal to 0 to x equal to 3. Okay. That means take limits now 3 square 9 minus g. Right. It is now how much? It is 9 joule. That is work done by that force. Okay. But actually we can solve same question. It is by using graph. So in the last lecture we have learned area under force displacement graph gives work done by that force, right? So we can solve same question more simple way. In more simple way, given passing through origin, this is F. Let us take when x equal to 3, force will be x equal to 3 means force will be 6, right? 6 Newton. And x is here in meters. Now we have to find area under the graph with the displacement axis. I will show here. The area which we are taking, that is now this part, yellow part. And that area is given by half base is 3. It is a triangle, right? So half base height. Height is now 6. Oh, here 3 times. 3 3 is 9. Right? The relation is that integration gives area under the graph. So taking directly graph, right? And finding the area under the graph. So this is more simple. Okay. So whenever you are given variable force, if possible, better we have to use area under the graph. That is now simplifying calculation part, right? Now see next one. Right, see the question. A block of mass 2 kg is placed on the top of a block of mass 3 kg, which is on a smooth horizontal surface. A constant force of 10 Newton is acting on the lower block horizontally. Find the work done by friction on the upper block in the time interval t equal to 0 to 3 seconds. So given coefficient of static friction 0.3 and that of kinetic 0.2 and z value 10. So we have taken t equal to 0, blocks were at rest. Okay. Right. So we have to find work done by friction on upper block. Let us see how we are solving the problem. Let us note down the given data. Given 3 kg block on a smooth surface and on that placing a 2 kg block on that placing at 2 kg block, applying a force of, see how much given, applying a force of 10 Newton horizontally on lower block, right? So given mu s, it is 0.3, mu k value 0.2. So in the time interval 0 to, in the time interval t equal to 0 to 3 seconds, work done by frictional force on upper block, right? So this is the data given. So first focus here between the blocks slipping is there or not, because if a slipping is there, then friction becomes kinetic. Okay, if there is no slipping, it will be static, right? So first of all, focus 2 kg block. This 2 kg block is moving only because of friction. Okay, it moves only because of friction. And that maximum value on 2 kg block, the maximum frictional force on 2 kg block is, it is limiting friction, right? And that limiting value, see how much? Mu is given 0.3. At this contact, normal reaction equal to 20 because G value 10, right? That means limiting friction on 2 kg block is 6 Newton. Okay, that means for 2 kg block, maximum acceleration, I am writing here for 2 kg block, for 2 kg block, I am writing A2. 2 stands for 2 kg block. For 2 kg block, maximum acceleration that is possible is, it is 3 meter per second square. Okay, that means up to this acceleration, both blocks will move as a whole. I am repeating, up to this acceleration, both blocks will move as a whole. Now see carefully. Suppose both blocks are moving as a whole. If they are moving as a whole, total mass equal to 5 kg, net force equal to 10. That means acceleration is, it is now 10 by 5. It is a 2 meter per second square. And here we have seen for 2 kg block, it can have maximum 3 meter per second square maximum. So this is now less than 3. That means both the blocks are moving as a whole. There is no slipping, right? No slipping means if you draw free body diagram for 2 kg block, so it is moving only because of frictional force, which is now static friction. That is now net force acting on 2 kg block. So we have to find now work done by frictional force on 2 kg block. So block is moving right side, displacement right side, force also right side. That means by static friction on 2 kg block, work done is positive. Because some students having a confusion like misconcept, by friction work is negative, and that is not correct. So here by friction on 2 kg block, work is positive. But if you take on 3 kg block, frictional force will be left side. I am repeating, on 3 kg block, frictional force will be left side, but displacement is right side. So by static friction on 3 kg block, work done is negative. On 2 kg block, it is positive. Now this value equal to, so I am saying this is now net force equal to mass into acceleration. Mass is 2 kg, acceleration 2. Therefore, net force is 4, which is nothing but frictional force. Now to calculate work done, we got force. We require now displacement. Let us calculate now displacement. Displacement equal to, they are starting from rest. Therefore, it is a half. Acceleration is 2. Half a t square. T given now 3 seconds, right? So 3 square. So it is now 2 gets cancelled. Check it once. Half. Acceleration is 2. So half a t square. 2 gets cancelled. 3 square is 9. Displacement is 9 meter. Force and displacement both are in the same direction. Therefore, angle is 0. Okay. So work done by frictional force on 2 kg block. Okay, on 2 kg block, that is 4 into 9 and angle is 0. So 4, 9, that is 6 joule. This is work done by friction on 2 kg block. Suppose the question is like on 3 kg block, then see what happens. Work done by friction on 3 kg block. Frictional force is same, displacement is same, but between these two angles is 180. So cos 180, it is minus 36. Okay. So like this we can calculate. So here what we have to keep in mind, work done by frictional force on which body we are calculating. Okay. So on 2 kg block positive, on 3 kg block it is negative. So here what we have to focus is whether blocks are slipping or blocks moving as a whole. That we have to confirm. Because if blocks are slipping, friction will be connected. Right? Let us move on to next problem. This is now previous IT problem. Let us see what is given. A force F bar equal to minus K into Y I cap plus X J cap, where K is a positive constant, act on a particle moving in XY plane. Starting from the origin, the particle is taken along the positive x-axis to the point a comma 0 and then parallel to y-axis to the point a comma a. The total work done by the force F on the particle is. So this question is asked in 1998 for 2 marks. So that time it was a subject to write. Okay, for 2 marks. Let us see how to solve it. So first write down the given data. F bar equal to minus K into Y I cap plus X J cap. Okay. So first it is taken from origin to a comma 0 along its axis. Then it is taken parallel to y-axis to the point a comma a. So in this process, what is the total work done? Right? Here you have to see carefully. Force is not a constant. It is variable, right? Minus K into Y I cap plus X J cap. Right? Let us see now. First focus work done along x-axis. Let us call it as W1 along x-axis. So integral F bar is minus K into Y I cap plus X J cap minus K into Y I cap plus X J cap dot. Let us take a small displacement dx along x-axis and dx into I cap. Students see carefully. We have to write F bar dot ds bar. Remember ds bar means we write ds bar means dx I cap dy j cap plus dz k cap. We are taking a small displacement vector. Now in this problem, it is moved only along x-axis. That's why there is no dy and no dz, only dx. So dx I cap. See how much we get. I cap dot I cap, that is 1. Remaining is minus k into integration of y dx. Integration of y dx. And this is equal to 0. Students, see carefully why it is 0. Because we are moving along x-axis. Along x-axis means what is y coordinate? It is 0. That's why it is 0. So no work is done while moving along x-axis. Okay, see carefully. I cap dot I cap, that is 1 y dx. J cap dot I cap, that is 0. Now see, while taking parallel to y-axis, I will draw a diagram here to get more clarity. So first taking along x-axis, then taking along y-axis, okay, to the point A comma A. Okay, right. So now we are moving along, means parallel to y-axis. Writing once again f bar dot minus k into y I cap plus x j cap dot. Now this time it is moving only along y-axis, moving only parallel to y-axis. Therefore, taking the place of ds bar, dy j cap, taking in the place of ds bar, it is a dy j cap. Then see what we get. Take minus k outside. Integration of I cap dot j cap, that is 0. J cap dot j cap, that is 1. So remaining is x dy. And see, when we are moving parallel to y-axis, moving parallel to y-axis means x coordinate is not changing. I am repeating, moving parallel to y-axis. Its meaning is x coordinate is not changing. Therefore, x is a constant. So take x outside and its value is a, right here. So I'm taking a outside minus ka. Integration of dy. So y value changing from 0 to up to a. Right? So at this point, y value how much? 0. Finally, y value is c. Then see what we are going to get. That is equal to minus ka integration of dy, that becomes y. Now take limits a minus 0. So this becomes now minus ka square. Okay, that becomes now minus ka square. Okay, so this is a way of solving the problem. Now same question we can solve. It is without taking a long x and a long y directly. Let us see how it is. Okay. So writing directly here, w equal to integral f bar dot ds bar. F bar is minus k y I cap plus x j cap dot ds bar. It is a dx I cap plus dy j cap, dy j cap. Okay. Now take minus k outside. It's a constant. Remaining is now integration of, see carefully, I cap dot I cap, that is 1. So y dx. It is y dx plus next x dy. It is x dy. Now coming to the next step, if you know mathematics, you might have learned that this y dx plus x dy can be written as d of xy. If you are knowing this, then you can write like this, y dx plus x dy, that is written as d of xy, means derivative of xy. Integration means it is now antiderivative, right? So antiderivative, and this is now derivative. So this becomes now minus k into xy. Limits are 0 comma 0 to it is a comma a. So then we are going to get minus k a square. Means if you know this mathematics, you can use directly like this. Otherwise, you have to solve in the same as in the first method. Okay, like this. Right? Now move on to the next problem. And this question also given previous IIT 2013 advance. Let us see what is given. The work done on a particle of mass m by a force. This is a force given. K being a constant of proper dimensions. When the particle is taken from the point a comma 0 2, that means this point is on x-axis, right? To a point 0 comma a. This is on y-axis. Along a circular path of radius c. About the origin in xy plane is. So it is taken along the circular path, right? And if you observe, x square plus y square is nothing but a square radius, right? A square. So this is now, let us write here separately. That force given, F bar equal to some k into x I cap by x square plus y square. In the place of that, I'm writing a square. This becomes a cube plus yj cap. This also now a cube. Okay. If you observe carefully, the direction of this force, this is now xi cap plus yj cap. Xi cap plus yj cap. If you take a circle, so this force will be along the radius vector. It is always along the radius vector because xi cap plus yj cap, it is along radius vector. But displacement, if you take small displacement, that small displacement vector is always along a tangent. Take a small displacement, that is a ds. Okay, so this is always along a tangent and force is always along the radial direction. So between these two angles now 90. That means directly we can say that no work is done, right? So answer is 0. So only one thing we have to identify that if it is taken along circular path, that is what given. So we have to see that this is along the radius vector. Okay. So angle is 90. That's why work done is 0. Right?